Hello everyone, this is my wireless communication class final presentation. My project name is OFDM simulation based on MATLAB. There are several parts in this presentation, and the first one is introduction. OFDM, also called orthogonal frequency division multiplexing, and this technique is a special multi-carrier modulation technique. It utilizes the orthogonality of the carrier wave to improve the spectral efficiency. It can also reduce the impact of the multipath fading and the narrowband interference. The principle of multi-carrier modulation technique is traversing the serial high-speed information data stream into a number of parallel low-speed data streams. Each low-speed data is modulated in each other's subcarriers orthogonally, and all the subcarriers are superimposed together to form a transmit signal. The pros of the OFDM is in this slide. Compared to the traditional single transmit system, the channel spectra of OFDM systems is overlapped and therefore have a high spectral efficiency, which almost twice than the single carrier system. At the same time, parallel low-speed data streams reduce the impact of wireless channel on system and enhance the anti-multipath and frequency selective fading. Moreover, OFDM equivalents the frequency selective fading channel to several parallel fat fading channels, which simplifying the channel equalization. The second part of the project is the description. Before we know what is OFDM, we need to first understand what is orthogonal. Sin t and sin 2t is the easiest situation of orthogonal. In the range of 0 to 2 pi, sin t and sin 2t are used to carry signals. We can call them subcarrier. The signal transmitted in the channel is A multiple sin t and B sin 2t. In the receiving side, after integral detection on the received signal, we can get the needed information A and B. We can see that on the left side are the signals sin t and sin 2t. On the middle of the slide is the combined signal, and on the right side of the slide is the signal that we needed. So two signals are orthogonal, means they can carry their own information without interfering with each other. And based on this principle, we can easily understand that cosine t is orthogonal to sin t. Likewise, cosine kt is also orthogonal to the orthogonality of the whole sin kt. Each subcarrier sequence is sending their own signals, overlapping each other and form ft. The receiver receives the hybrid signal ft. After multiplication of the integral operation in each subcarrier, we can get the signal which carried on the subcarrier. Then, now we understand what is O orthogonal. Then, let's see what is FDM and the difference between FDM and OFDM. The regular frequency division multiplexing system is just like the picture below. There are intervals between each two signal spectrum. It prevents signals interfering with each other. But if we take the hardware implementation into consideration, if two subcarriers is close to each other, it is difficult to completely remove the impact of the second. If interval frequencies are orthogonal to each other, even if the spectrum is overlapped, the subcarriers will not interfere with each other at all, and this is OFDM. See this picture? Two subcarriers spectrum is overlapped with each other, but they will not interfere with each other. There is one communication channel called relay fading modulation, and this modulation is used to statistic the impact of transmission environment on my OFDM system. There exist different delays in high-speed data transmission. Fading relay channel is fast fading in order to decrease the effect of the delay. This is the flowchart of my project. And the fading channel now is on the very right side of this picture. And estimator is also used in this project. I'll introduce two estimators. The first one is ZF estimator. ZF estimator, also called zero forcing estimator. Zero forcing estimator is based on zero forcing equalizer algorithm. This algorithm is usually used in communication systems. Zero forcing algorithm is to multiply the received signal by the inverse of the channel matrix. The response of the equalizer is the reciprocal of the ISI channel, and it can completely eliminate the interference from each other channels. However, at the same time, the noise is multiplied by the inverse of the channel matrix. The second estimator is called minimized mean square error estimator. The idea of minimized mean square error algorithm is very similar to zero forcing algorithm. Both of them is trying to minimize errors. However, minimized mean square error estimator would get better performance than zero forcing estimator in theoretically, because minimized mean square error estimator take noise into consideration. Experiment. In this experiment, two different frequencies is set for both estimators, 40 Hz and 80. Then, we applied minimized mean square error estimator and zero forcing estimator in relay fading channel, and here are the results. The blue line in the picture means the zero forcing estimator, and the right line means minimized mean square error estimator. We can see several conclusions from these two pictures. The first one is the performance of minimized mean square error estimator and zero forcing estimator is very similar when the noise is kind of low. The second one is ZF estimator has better performance than MMSA estimator when noise is very low because of the simplicity of ZF. And the third, minimized mean square error estimator has better performance than zero forcing estimator. The noise is kind of high, and when noise is increased, BER is also improved. And this is my presentation. Thank you.